The digital Tower of Babel. Imagine you're trying to explain the concept of existential dread to a toaster. That was the state of networking in the 1970s. Every computer manufacturer spoke a different digital dialect. IBM didn't talk to DEC, and Honeywell was off in a corner screaming in binary. It was a digital Tower of Babel where wires only worked if they were from the same cult. Then came 1984, not the Orwellian nightmare, though some Cisco engineers might disagree, and the International Organization for Standardization (ISO) dropped the OSI model. Think of the OSI model not as a physical thing, but as a rigid, 7-story bureaucratic office building through which every cat GIF must travel to reach your screen. It's a conceptual framework that breaks down the impossible task of sending a poke on Facebook into 7 manageable layers of suffering. Without it, your internet would just be a series of sparks and sad noises. We're going to climb this tower from the penthouse to the basement. It's going to be confusing, slightly illogical, and involve more headers than a soccer match. Grab your packets. We're going deep into the stack where the sun doesn't shine and the pings never end. Layer 7. The application layer. The face of the operation. We start at the top. Layer 7. This is the only part of the networking world that actually likes you. It's the customer service desk. When you open Chrome, Firefox, or that one obscure browser for people who think Google is watching their thoughts, you're interacting with the application layer. Protocols such as HTTP, SMTP, and FTP operate in this layer. This layer doesn't run the app, it's the window the app uses to shout at the network. If you send an email, Layer 7 is the one that says, "Cool, I recognize this is an email. Let's get the SMTP protocol to start the paperwork." It's the most human-centric layer, which also makes it the most prone to being blamed for things that aren't its fault. The internet is down. Is usually just Layer 7 having a minor stroke because you typed Google into the address bar and hit enter. It's the flashy marquee on the front of the theater. Everything below this is just stagehands in black shirts moving heavy boxes in the dark. It's where your digital journey begins full of hope, unaware of the compression and encryption-based trauma about to occur on the floors below. Layer 6, the presentation layer, the digital translator. Welcome to Floor 6, the presentation layer, or as I like to call it, the international spy and gift wrapper. This layer has 2 main jobs: making sure the data is in a language the receiver understands and making sure it isn't stolen by Russian teenagers. If the application layer says, "I have a picture of a cat," the presentation layer translates that into a specific format like JPEG or PNG. It's essentially the translator at the UN, turning meow into 011010101. But wait, there's more. This is also where encryption happens. Before your data goes any further, Layer 6 wraps it in SSL TLS, the digital equivalent of putting a top-secret sticker on a lunchbox. It also handles compression. Why send 5 megabytes of data when you can squish it down to 2? It's like vacuum packing your clothes for a flight. It's still your shirt. It just looks like a flat piece of beef jerky until you unpack it at the other end. Without Layer 6, your computer might receive a file and think it's a recipe for lasagna when it's actually a high-resolution photo of a potato. It ensures the presentation doesn't ruin the surprise. Layer 5, the session layer, the awkward middleman. Layer 5 is the session layer. If the OSI model were a dinner party, Layer 5 would be the guy who checks the guest list and then stands between 2 people to make sure they're actually talking to each other. Its job is to establish, manage, and terminate sessions. When you log into your bank, Layer 5 opens a session between your PC and the bank's server. It stays open as long as you're active and then slams the door shut when you leave. It's also the king of checkpoints. Imagine you're downloading a 10 gigabytes file of educational videos. At 5 gigabytes, your cat trips over the router. Without the session layer, you'd have to start from 0. But Layer 5 adds sync points. It says, "Okay, we've got 5 gigabytes, let's save our progress." When the connection returns, it resumes from the last checkpoint. It's the digital equivalent of a to be continued screen. It manages the flow, ensuring that if you have multiple tabs open, the data meant for YouTube doesn't accidentally end up in your work Slack. It's the traffic controller of the conversation, making sure the digital dialogue doesn't turn into a chaotic monologue. Layer 4, the transport layer, the logistics manager. Now we hit the heavy hitters. Layer 4, the transport layer, is where things get technical and slightly aggressive. This is the logistics manager. Its primary protocols are TCP and UDP. TCP, Transmission Control Protocol, is the overly attached girlfriend of networking. It sends a packet, waits for a receipt, and if it doesn't get one, it sends it again and again. It's reliable but slow. UDP, User Datagram Protocol, on the other hand, is the cool uncle who just throws the data at you and walks away. Did you get it? I don't care. I'm busy. Great for gaming and streaming, terrible for important bank transfers. Layer 4 also handles segmentation. It takes your giant cat GIF and chops it into tiny, bite-sized pieces called segments. It numbers them so the other side can put them back together like a Lego set. It also manages flow control. If your server is screaming data at 1 gigabits per second, but your phone is only receiving at 10 megabits per second, Layer 4 tells the server to chill out so the phone doesn't explode. It's the layer that ensures the data actually makes the trip without getting lost in the digital woods. It's the unsung hero of the buffered wheel. Layer 3, the network layer, the GPS of the internet. We've descended to Layer 3, the network layer. This is where IP addresses live and where routers earn their keep. If Layer 4 is the logistics, Layer 3 is the GPS. It looks at the segments from above, turns them into packets, and slaps a destination address on them. It doesn't care what is in the packet, it just wants to know where it's going. It's like the postal service. They don't know if you're mailing a brick or a diamond, they just see the zip code. This layer is responsible for routing, finding the best path through the web. The internet isn't a straight line, it's a messy web of cables. Layer 3 decides, okay, the path through New Jersey is blocked because a squirrel chewed a wire. Let's go through Virginia instead. It handles the logical addressing that allows your computer in Ohio to find a server in Singapore. Without Layer 3, your data would just wander around the neighborhood like a confused Roomba. It's the brains of the operation, navigating the vast, dark wilderness of the global network to make sure your LOL reaches its target. It's the layer that makes the worldwide part of the web possible. Layer 2, the data link layer, the local traffic cop. Lowering down to Layer 2, the data link layer. While Layer 3 handles the global map, Layer 2 handles the local neighborhood. This is where frames and MAC addresses are found. Every device has a unique MAC address, a physical fingerprint burned into the hardware. Layer 2 doesn't care about IP addresses. It just wants to know which physical device on your local network should get the data. It's the switch in your closet. Layer 2 is also the local traffic cop. It checks for errors. If a packet arrives and it looks like it's been through a blender, Layer 2 throws it in the trash and asks for a new one. It also handles media access control. If two computers try to talk at the exact same time on the same wire, they'll collide, creating a digital mess. Layer 2 manages this by saying, you go first, then you. It's essentially the etiquette coach for your hardware. It takes the packets from the network layer, wraps them into frames, and prepares them for the final, most brutal part of the journey, the physical world. It's the last stop for logic before we hit the pure physics of the basement. Layer 1, the physical layer, the basement of reality. Finally, we reach the basement, Layer 1, the physical layer. This is where the magic ends and the physics begins. There is no logic here, only pulses. It's the cables, the fiber optics, the radio waves, and the actual copper pins. Layer 1 takes the frames and converts them into pure bits, ones and zeros. These are then sent out as electrical voltages, light pulses, or microwave frequencies. If your dog chews your Ethernet cable, that's a Layer 1 failure. If your neighbor's microwave interferes with your Wi-Fi, that's a Layer 1 problem. This is the only layer that actually touches the physical world. It's the dirt under the fingernails of the internet. It defines things like how many pins are in a USB connector or how fast light can blink through a glass tube. After the data travels through this physical gauntlet, it arrives at its destination and begins the long climb back up the OSI stack, being unwrapped at every floor until it becomes that cat GIF on your friend's screen. 7 layers of complex, obscure, and often annoying bureaucracy, all so you can send a meme. Isn't technology beautiful, or at least incredibly over-engineered?